So, welcome everyone. This is Naghmana. So, today we will complete our Maths Exam 1 2020. We'll starting with question number 9. That's the last question of this exam paper. So, let's start with that. Consider the unit circle with the tangent to the circle at the point P shown in the diagram. So, we have given is a unit circle. And whenever you see the question, the first thing you should recognize is, oh, what is given? So we know this is a unit circle, that is length 1, and this point is 2. So where we can see that this whole length is 2, so it's a 1, 2. And I just think we have a right angle triangle. Right angle triangle, this length is 1 and that's 2. So we can clearly see that, oh, this is 30-60 triangle. So this would be by using Pythagoras theorem, that is root 3. And this one here is our angle, and that's the angle theta with the origin. And we can see that because the question is asking, show that the equation of line passes through the point A and P is given by that. So we're looking for this equation which is passes through A and P. So there are a couple of things we could see. That's, let's say this angle is theta, and then we can use that triangle to work out what is our theta. And we also clearly identified that this is 30-60 triangle. But let's say if you didn't recognize that, you can still use, say, cos theta is equal to 1/2, and that will give you theta is equal to pi on 3. So this is our pi on 3, and this angle is theta here is pi on 3. If that is pi on 3 and the other one is pi on 6. So this is our 30-60 triangle. So now other thing we need to recognize is this line passes through point A and B, that is a tangent line, and the tangent line making an angle with positive x-axis, where we can find, we know we have that result, which is m is equal to tan theta. Okay, so that's where we can get the gradient of the line. Okay, so that means that would be the OP, gradient of what? OP line there. So I've just put an OP there, or just name that. So this is a gradient of the line OP. And we know that is equal to tan pi on 3, and that is equal to root 3. So that's the information which will be helpful now for us to see that the line OP is perpendicular to AP. If they're perpendicular, that means the gradient of the line AP would be equal to negative reciprocal of gradient of OP, which is -1/√3. So we got the gradient. Now we also need this point P, the coordinate of that, which we know. The x coordinate is what? Cos theta, which is 1/2. Y coordinate is sine theta, which is √3/2. So we know this point now, and we can find the equation of the line passes through this point. So we go y minus √3/2 equal m, which is -1/√3, x minus x1 is 1/2. And then just rearranging it, take the √3/2, -1/√3x plus 1/2√3, and then plus √3/2. And then we will simplify that. This will give us -x/√3. And if we make this as same denominator, we get 2√3, 1 plus 3, which gave us 4/√3. So that is equal to -x/√3 plus 2/√3. So that's the question. That was the question. So we got that equation line, which is passes through that point, and we used all those facts, and we got the equation of the straight line. So remember that whenever we have this show that question, show that means you have to really set it up properly and show your working out is whenever because the answer is already given, so you will be these 2 marks mean you have to set it up properly, give all the details, and write your steps in detail, or show your logic behind that. How do you work that out? Okay, now let's look at the question number 2. Which says in the second part of that question, number 9, so we have the transformation where Q is there, which is the dilation factor. Let the graph of the function h on the transformation of the line passes through the point A and P under that transformation. Find the value of Q for which the h intersect with the unit circle at least once. Okay, at least once. That's very important point here. So it's going to be at least once. That is, so the Q here is what is a vertical dilation. Okay, so vertical dilation which is by factor Q. And what that could be, because we want that to intersect once, so that means the value of the dilation factor has to stay between 0 and Q has to be between 0 and 1. Okay, so let me write that Q like this. So Q is between 0 and 1. It has to be 1. It's going to touch that, and that's the only. And after that, it's not going to intersect the circle. So we want to make sure that is the thing. So that's one thing to pay attention on. And then what is the other possibility of that? If I say when the line would be, that would be when it is something like this. Then it would be the second scenario when we're saying, and that would be reflection in the x-axis. Okay, so what does that mean? That means Q has to be less than, Q has to be between -1 and can't be the 0. So that implies now the Q can't be 0, but it's between -1 to 0 and then 0 to 1. So that would be our interval for that one. Okay, so now we look at the second part of this. So now they say the graph H. What is the H? H was the transformation one, and the unit circle twice, and find the value of Q for which the coordinate of the point intersection have only positive values. Okay, so that means it's intersect twice. So we need to see what would that be look like. So if you see that, it would be something like, if I draw that would be something like this. It has to intersect 2 points. Okay. This is just to show you. So we know that. So it's gonna in the Q values, that's the values of the Q we're looking for. The point of intersection have only positive values. So we need to make sure that it's going to be positive. So how we can make sure that means the Q, one thing we notice that it has to be less than, Q has to be less than 1, right? And because this factor there, this point here, right, this coordinate is 0 and 1, right? 0 and 1, you could find the equation of straight line straight away from there, which is not that required. But if you want to see that, what would be that line passes through this point and this point, that straight line would look like x plus 1, and then there we have the y, the gradient would be -1/2. So that would be the line, the pink line is there. But that's not required here, but we just need to make sure that this, what would be the Q values there. So the other thing we know is to this point here is P point was √3, and this value there would be 2 over, because we know this y-intercept there, which from the previous question, we know this is 2 over root 3. Okay, so we're saying that is 2 over root 3. So what does that mean is the q has to be greater than the other thing. You could see that the q, and if you multiply with that factor, that has to be greater than 1, or you could write it like this: q has to be greater than root 3 over 2. Okay, so what does that mean? That means we know, we make sure that q is root 3 over 2 to 1. So that's the value of the q when we are making sure that that will have the unit circle twice and it has a positive values. Okay, so now we have the C part of the question. So which we say we got the value and say Q is between 0 and 1, and P dash is the point of intersection of H with the unit circle, where P dash is always the point of intersection that is closest to A, right? So we have this, the point of, we're looking for the graph H, the Q value is given, P dash is the point, right? And always the point of intersection closest to A. That's a make sure thing. That we need to define the G function that gives the area of the triangle OAP. So OAP dash. So if you see that, that's the triangle look like this. So P dash is there, O, and this is theta, and this one is A. So for that triangle, area of the triangle is half times base times the height. So in this case, the area would be equal to 1/2 the base length. We know that is equal to 2, right? This length is 2. And then height would be, if you want to find out this height, we know that height would be sine theta. Yeah, so that gives us that the area is equal to sine theta. So that means we can define our g function, like say, you say your g function would look like, so g such that we need to write it properly, like the way we define a function, which would be from 0 to that point coordinates are 0 to pi on 3, right? So this is included to R, and then we say g of theta is equal to sine theta. So that's our function. Okay, now next part of the question is determine the maximum possible area. So where would be that maximum value would occur? So we need to make sure where that, by looking at the, this what we want is, we want that they said the closest, the point has the, remember that this P dash always have to closest to, must be the closest to the point. So that to the point A, that means the maximum area would occur where theta is pi on 3. Where theta is pi on 3, that would be the where the maximum area would be. Maximum area would be sine pi on 3, which is equal to root 3 over 2. So that's where it is. So because we just need to really clearly look at the domain of the function and realize that, okay, that would be the maximum point where that will, the area would be maximum for this one. Okay, I think that's it. Thank you very much. So exam 1 is complete. Please, if you like this video, please share and subscribe to the channel. Thank you.